At this point, you've seen an example of the 3 types of hypothesis testing we're going to do. So I encourage you to pause now and try to do this problem on your own, and then come back and see if you got it correct. A manufacturer claims that fewer than 6% of its copiers are defective. In a random sample of 97 such copiers, 5% are actually defective. Test the manufacturer's claim at the 0.05 significance level. Now, in this case, the claim doesn't actually have the sentence behind it, but up here, the claim does. So, fewer than 6% of its copiers are defective. If I write my hypothesis, H sub 0, H sub 1, we're talking about a percent, so that's a P. P equals 0.06. P is less than 0.06. Fewer than is less than. And as we've done before, label the claim as the less than. Now, at this point, if you wrote down what you needed to type into the calculator, the first thing, P sub 0, is the number from the hypothesis, so 0.06, and then you need a part in out of the whole, that's backwards, a part X out of the whole in. Now, we definitely know that the whole is 97 copiers, but this one requires one extra step. And it's an important step we saw back in Chapter 7 with confidence intervals as well. We need to find 5% of 97. That, of course, is 0.05 times 97. But if you put that in your calculator and you multiply it, you're going to get a decimal. Well, you can't have 4.85 copiers, so you must remember to round it to a whole number, or you're going to get an error on the test. So even though it says 4.85, we round that to 5 copiers, and that becomes our X. So 0.06, 5 is the X, N is the 97, and less than will be what we highlight. Since it's less than, it's left tail, and since it's a P percent, we're using one prop z-test. So we can go to our calculators, stat, right arrow to tests, and number 5. I've already put in 0.06, 4.85, 97. And if I leave that as a decimal, I wanted you to see, you will get an error in the domain, which if you remember your algebra, that's the X. And so we're going to press quit, go back. What I did want to show you is that under the X value, you can actually put 0.05 times 97 right there. When you press enter, it'll give you the 4.85. You round it in your head, go back, and type the 5 on top of the 4.85. Now everything is a whole number, and we can draw. Left tail is shaded in. There's our z-score. There's our p-value. Remember, the z-score is just another name for the test statistic. So the test statistic, z, is negative. What was it? Sorry. It is negative 0.35. I was looking at something else. Negative 0.35. Our p-value is 0.363, and our alpha back in the problem was 0.05 significance level. When we compare these, 0.363 is greater than 0.05. If the p is high, then the null will fly, which means fail to reject. Our claim is less than, and our decision is fail to reject. So when we look on our formula chart, number 2 is fail to reject and does not include equality, which would be the less than. So it is the number 2 sentence. I'm going to be a little lazy and just write number 2, but you could write it out. There is not sufficient evidence to support the claim that there are fewer than 6% defective copiers.